So friends, good morning. Today we are going to study unit number 3, welding of plastic. So as I told, welding means joining. In earlier manufacturing processes or molding processes of the plastic, you have seen that number of unique components are produced by plastic molding process. There are many big components, big assemblies where you require to join the plastic parts. So to join the plastic parts, number of processes are used depending upon thickness, depending upon size, depending upon material, depending upon the complexity of the product. The different welding processes are evolved. So welding word is not old to you. So after welding word is not new to you. This is a very old word. You have already started from maybe before joining the engineering also you were knowing this word. Now in this process, joining up to metallic component where the base metal temperature was maintained, that was applicable to metallic welding process. Same concept, joining up to plastic components where the base metal, now this is not base metal, this is a base plastic. So base material, I will use the word instead of word metal. So base material temperature, its melting point. Then now, not only melting, but one important thing is degradation temperature. Remember this. This is the important difference in welding of metallic parts and welding of plastic. So welding of plastic, you are going to plasticize it, but you have limitation of heating. You have limitation of heating means don't go on so high temperature that the degradation of plastic will start. Means it will start losing its properties. It will start losing its properties. So that care should be taken, and accordingly around 400 degree Fahrenheit to 700 degree Fahrenheit. I am saying Fahrenheit. 400 degree Fahrenheit to 700 degree Fahrenheit, maybe around 150 degree Celsius to 250 degree Celsius. So heating temperatures are kept or adjusted, and then joining up to plastic part make us possible. Okay, so aim of this chapter or outcome of this chapter is at the end of, see, already you are in 8th semester. From start with semester 1, every subject's outcome, every chapter's outcome you are familiar with. So as far as the requirement of NBA is concerned, so every course have its outcomes. So starts with chapter outcomes. So what is the outcome of this chapter? At the end of chapter, students will be able to explain different plastic welding processes as per the applications. So at the end of chapter, every student can select the suitable welding process. So CO, we have different COs. Out of that, one CO is select the suitable plastic molding process and plastic welding process as per the application. So this chapter works on that CO. So now let us see the classification of these welding processes. What we are going to cover here, we are going to cover 4 to 5 processes. Hot gas welding, hot tool welding, you can write one below other. Hot gas welding, hot tool, hot gas welding, hot tool welding, then high frequency induction welding, infrared welding, nuclear welding. So how to join plastic components? Welding means joining process. How to join different plastic components? The different plastic components are joined by using these following methods: hot gas welding, hot tool welding, high frequency induction welding, infrared welding, and nuclear welding. So with the help of these processes, we are going to study the joining of plastic. And why joining is required? Why welding is required? Because when it is not possible for us to produce so complicated components, and when there is a limitation for, see, more and more complexity of the component, you are going to change, you have to change the design of die. And for your kind information, even you want to manufacture the simple plastic component, you require metallic die. Die steel is used, and that metallic die, so you don't count it that weight of the die is 10 kg and how much is the steel cost. Don't go by that way. So its design cost, its manufacturing cost, and other costs goes beyond 2 lakh, 3 lakh rupees for simple die, and goes beyond 20 lakh rupees for complicated die. I repeat once again, cost of die goes beyond 1 lakh rupees many times for little simple component, and may go beyond 20 lakh rupees for larger and complicated components. That's why if you go on increasing the complexity in your product, you have to compromise. Means you have to bear the cost of die. That's why little complexity is compromised, and it was made possible by joining the components, so that you will get the unique component after joining. Okay. Now hot gas. Here there is no in actual welding of the metallic parts, is in gas welding. Gas welding means the gas was used for making the flame. Here there is no flame. Remember, the one more difference in welding of plastic and welding of metallic parts or alloys. Gas welding, where acetylene gas, hydrogen gas, its combinations were used for producing the flame, and that flame was held against the metallic part to melt it. Here, this gas is not going to make any flame. The gas itself is hot, and that hot temperature, that hotness of gas, the temperature of that gas causes melting and plasticizing of the plastic. Usually, air is used. Simple. Hot gas means hot air. So, from where to make the, otherwise you have to use some gas like argon, which will not make any reaction on the neutral gases are supposed to be used. So, best way, hot air. Hot compressed air, hot air, not compressed, hot air is used, and it is forced against the joint through the nozzle. The temperature of air was maintained in some of the separate chamber, and then our heaters are made, and through that heater, hot air will enter into the nozzle, and from nozzle it will enter into the joint, and then that hotness or that temperature of air causes the melting of part which is to be joined. So there is no flame as such. So I repeat once again my statement. In case of gas welding of metals, gas is used for making the flame. Gas burns there. There is no combustion. There was combustion. Here there is no any combustion. Remember, this is main difference. Hot tool. So some metallic tool is used which is made hot, and that is used for plasticizing the plastic. Everywhere, the aim is to plasticize the plastic, to make plastic semi-solid. Okay. Then high frequency induction welding. You know the induction principle, when current is carried through primary, secondary generates, and then the processes is carried out. Infrared rays are used for heating the plastic surface, which will make it into reaching to the plasticized zone. And then nuclear means bombardment of the protons, etc. is used for providing the heat. Aim of every process is to provide the heat. I repeat, aim of every process is to provide the heat for plasticizing the plastic. So let us see one by one. First, you write down hot gas welding. I'll draw the figure, you can draw along with it. simple figure. This is called as beveling. So making the bevel like shape notch so that filler material can be filled. So this is the source for hot gas or hot air through which heat generated, and then it will cause melting of this base plastic as well as filler plastic. These are two base plates. Draw this simple figure. So this process is used for joining many thermoplastic materials. The temperature, I told, temperature of heating is varying around 425 to 700 degree Fahrenheit. 400 degree Fahrenheit to 700 degree Fahrenheit. So how to convert degree Fahrenheit into degree Celsius? You must know. Degree Celsius upon 100 is equal to degree Fahrenheit minus 32 divided by 180. You can write this formula somewhere at the upper side. So convert this 400 if you put here, then accordingly Fahrenheit, if you put 400 here, if you put, then accordingly you will get degree Celsius. So C upon 100 is equal to F minus 32 upon 180. Temperature is that temperature. Hello, Mr. Narule, where is your roll number? Please join with roll number. I repeat, Mr. Narule, please join with roll number. So temperature of this gas is maintained by some particular or gas or air is maintained by a particular mechanism, and there is a control wall. So there is a knob. Through that knob, the flow of air or gas is controlled and pressure is also controlled. See, remember, the pressure of air should not cause the spreading of plastic. Instead of accumulation, it should not get spread. That is important thing. Otherwise, if you use pressure, hot air with pressure, then what will happen? Whatever molten plastic is there, it will spread away. This should not happen. So skill is a little required here. And the pieces which you want to bond, I already told, it must be produced with V-shaped joint or it must be beveled. Okay. And one important logic, same as like metallic welding. What is that logic? This material, filler material, must be of same material as that of base material. Otherwise, there will cause mismatching of the properties. And whenever filler rod you are going to put, this filler rod is held against, see, I have shown in the same way. It is held against the hot air so that it will melt and it will fall. Material will fall in the gap in the terms of droplet. So fade into joint and heat from the gun is directed at the interface. when chapter of welding in manufacturing process, there I think, I don't know, are you remembering or not? So different way how metal deposition takes place. As a curiosity, you can search that book and check the metal deposition processes. Now here is no metal, here is a plastic. But whatever material deposition takes place, it is by different mean. So what electrode you are using in that metallic welding, consumable electrode, how it goes into gap. Either it goes directly in the terms of droplets, or it may go in the terms of sprays. So that process is totally different. Here, plastic rod is heated by hot air. It will be plasticized. Material will fall in the gap, and at the interface again, the gun is held so that complete joint will be produced by mixing of filler at the joint, and then after cooling, you will get strong joint. And this molten product is directly at the interface, and it fills the gap. Whatever gap you have provided, accordingly, this gap is filled by this rod. And here, after cooling process, your aim is the joint which is produced should be very strong joint, as like unique component. A strong fillet must be formed, which is having considerable importance. Otherwise, if you just join and fill the plastic material at the gap, and there is no combination or there is no complete mixing of base metal with the help of filler material, then your joint will not be strong joint, and it will not remain for long time, and there will cause failure of the joint. And one important thing, I am repeating this statement once again. What temperature you are providing here? Its range is given by me. So you have to check this temperature with melting temperature of this plastic and degradation temperature. There is no question of degradation of metal in metallic welding, because melting point, suppose 1000 degrees Celsius, you are providing the heat, and temperature raised up to 1100 something, and no problem, the molten metal and filler rod get combined here. But here there is a problem, because this plastic is polymer based material. Plastic is polymer based organic material, C and H elements are there. If you will heat more than optimum temperature, okay, no problem, melting will be fast, joining, combination of the filler and base metal, everything will be achieved. But on the other hand, the degradation, plastic will start losing its properties because of high temperature of the air or gas. That's why your heating temperature must be maintained in such a way that it will just melt, it will just make plastic semi-solid, it will just plasticize the plastic, so that there is a mixing of filler into the gap of two base plates. No any other requirement other than this. Overheating will cause this degradation. So even in metallic parts, overheating and burning is one of the defect in forming processes. Burning, so it becomes blackish and it will lose its properties. That's why in metallic welding, there is very important concept in metallic welding. And what is that? Can anybody tell? Now this question goes to you. In metallic welding, the surrounding area is called as something. I want answer from your side. You can do your research work on it. So interested topic. Ajinkya Jadhav, roll number 23. Roll number 23. Roll number 23. This is the problem of your class. You are not alert. Who will tell willingly? I want answer. What is this area called? Narayan Vyavare. Narayan. Mr. Narayan Vyavare. Hello, Mr. Narayan Vyavare. Are you there? Akash Kendre.
Yes, sir.
Answer my question, Akash. My question is, this is a building area. What it is called surrounding the building from both the sides? This is one zone. I have given 50% answer to you. What is this zone called which is around the building spot or building area? Yes? You don't know this, Akash?
No, sir, I do.
You are in 8th semester, Akash, mechanical engineering. Not only you all people. This is called as heat affected zone, HAZ. You have studied in second year. Heat affected zone. Are you knowing this?
Yes, sir. Yes, sir.
Have you heard this word?
Yes, sir.
Okay, now you can unmute. Sorry, mute. So, there was concept of heat affected zone in metallic parts, and in turn, we have studied metallurgy also. So, if steel you are joining, then surrounding to it, because of heating and cooling cycle, there is a phase change, and because of that phase change, if your base steel is perlite and you don't want to change it, sometimes the phase near to it becomes martensite bainite, or if it's already martensite and you are joining it, because of air cooling it becomes perlite once again. So that's why that zone is called as heat affected zone. So here in case of plastics, you can consider this as a heat affected zone, but that's why to avoid the degradation, you must care that the heating temperature of gas or air should be optimum just to fulfill the purpose of melting, not for extra heating to avoid the degradation. And air is used best because it will not affect any other properties, and plastic material like polythene and other similar types are oxidation, and that's why hot gases are hot gases and hot air. The selection must be proper. If some gases you are using and that gases may sometimes be safety gases, neutral gases, that gases may be selected instead of air. Many times air may cause the oxidation, and to avoid it, the neutral gases are also selected. That's why the name of process is hot gas process, and air is considered as one of the gas. So to avoid the oxidation, the hot gases which will not cause any oxidation are also used. And the most commonly used hot gas is nitrogen. Nitrogen gases are used. And once welding joint is prepared, whatever stresses are generated, and that stresses may be relieved. What happened after the welding joint should not be stressed. Here you produce the joint, and if you try to check it, it will break because yet you have not permitted for the cooling. And you should not elongate it, you should not put it under compression, you should not put it under stress, because till outer side you may feel that it is solidified, but from inner side it is not solidified because polymers are bad conductor of heat. Very important thing. Metal, there is a chilling effect, but in case of polymers, when it comes in contact with atmosphere, upper area gets solidified, but inside part may be still soft and plasticized state. And if you put your finger, I will say in Marathi, you can check this palm. Check this palm. If you press, you feel that it is going down. म्हणजे काय होतंय, वरून जरी टणक वाटलं तरी बोट तुम्ही दाबलं त्याला तर ते आत मऊ मऊ असणार आहे. आर यू गेटिंग माय पॉइंट? मीन्स व्हॉट? अप्पर सरफेस गेट सॉलिडिफाईड but inner part up to the base of the joint it will not solidified easily as these plates are thicker. That's why remember in chapter number 4 we are going to talk on this minimum wall thickness. So wall thickness is very important. If larger thickness you select, it takes hours and hours to cool because polymers are bad conductor of heat. It is not like metal, and hence these parts should not be disturbed for particular period, maybe in hours, till it will not completely solidified and completely come out of plasticized zone. And mainly used materials are polythenes, nylons, formaldehydes. Okay, and this process is usually hot gas welding process is recommended for thick sheets more than 6 inches. See, in day-to-day life, we are observing some thin components of the plastic. But at industrial sectors, there are many thick parts, 2-inch thick, 3-inch thick components. And such components are joined by hot gas or hot air process. So around 4-inch to 6-inch. 4-inch to 6-inch size. And the welded product is not commercially attractive. Very simple. Joining with the help of hot gas or hot air and that filler material is going inside. So attraction or that aesthetic look, design you have seen. So commercially attractive. The product will not be. That's why for some other processes like high induction, this high frequency induction welding, etc. Their products are attractive products. So because welding is very precise in that case. Here there is no precise welding. That's why product is not attractive, and this may be considered as one of the limitation of the process. And we can say one more thing, that tensile strength is near to 80% as that of parent strength, parent material or parent or base material. If tensile strength is suppose 200 for this base, so the joints tensile strength may be around 180, 80 to 90%. So that much strength you can achieve with the help of hot gas welding process. And where it is used, large structural assemblies, wherever in industry you have seen there are big structural assemblies made of plastic, this process is employed. So I repeat once again, I will take review in 1 minute. Hot gas welding, actually gas or air is used just for providing the heat to the base plate or to plasticize the joint and filler. There is no flame as such as like gas welding in metals. I repeat once again, many students are get confused. Gas welding in plastic does not produce any flame. Gas itself is hot, air itself is hot, and the heat from that gas or air is taken for plasticizing the plastic. Range is 400 to 700 degree Fahrenheit, and accordingly the minimum temperature for plasticizing is achieved. Extra temperature, extra heat will cause the degradation of the base plate. These polythenes and other material, there may be chances of oxidation. Hence, preferably gas is preferred, maybe nitrogen gas. The thickness is more. Thickness may be 4-inch to 6-inch, and it is used for large structural joints. Okay, this is all about hot gas welding process. Subjective question may be asked for 3 or 4 marks. We have covered many MCQs here. More than 4 to 5 MCQs are covered in my explanation. Okay, that they are provided in the booklet, no problem. But whenever I am telling some important things, you must immediately note it down. This temperature of heating, okay, then thickness of the plate, which gas is used, what is the filler materials requirement, and how hot gas or hot airs are performed for heating purpose, and the part which is joined should be kept for sufficient long time. because thickness is more. I repeat once again, part which is welded should be kept for sufficient long time till complete solidification at the joint. It may take hours. Okay, and that is the you can consider as a process time is more as a disadvantage. Otherwise, if you try to stretch it or pull it or hold it, the inside part, as I have given example, outer surface may feel strong, but inner part may be still in solidifying range, and you may cause breaking of the component in between. This is all about hot gas welding. So I hope you have drawn the figure. Next, let me explain hot tool welding. You please draw this figure. I hope you have drawn, and I have not dictated as such. Whatever I have explained to you, I hope you have noted down the points. Notes will be provided to you. Don't worry. How many of you have seen this process in day-to-day life? Now, general question I'm asking. How many of you, okay, I understand this hot gas or hot air you may not have seen. So, please tell me how many of you have seen this process in your day-to-day life? Hot tool or heated tool welding. Sometimes it may be called as heated tool or hot tool welding. Joining of plastic with the help of some hot tool. This is a very general question. Even I will ask this to other branch student. They can answer this. So please reply to my question. Little participation is required. Shubham Bansode, roll number 8. In drainage pipe joints. Okay, drainage pipe joints we have seen. How it was, how any hot tool was used there? Tool. Drainage pipe joints, the people may be just heating and putting one pipe in other. Abhishek. Circular plate. Correct. So, one thing Mr. Shirsagar has answered correctly. Any other process where the plastic is joined by using some of the metallic tool which is hot. Any other student? Asture Chandraprabha, roll number 1. Roll number 1.
In thermos flask.
Thermos flask? Where?
Outer coating metal असतं आणि inner coating plastic.
I'm not asking you the product. This is process we are studying. Process of joining where you have seen actually in day-to-day life. That Shirsagar has given correct answer that he has seen in joining two pipes. So there was joining. Here you have seen in different grocery shops or malls, the polythene bags packed with the grocery material is packed with the help of one press heated tool. Or you might have seen some of the heated tool or plate is kept. If you go near to Mandir side, you will find the prasad material they are packing and holding against one hot plate. So your polythene bag gets packed. Packing of your polythene bag is the best application or example of heated tool welding. If you have not seen, go to any grocery shop or any mall where packing is going on. Material they are putting inside. So in this way, I will show. Assume that this is plastic bag. Now material they are putting inside, and then they are just holding in this way and forcing against some metallic plate, or this is kept in this way, horizontal way, and there is one handle where the metallic plate is kept at the back, and they are just pressing it down. The electric current makes or causes heating of that metallic plate, and when you press it down, these two plastic films get joined to each other. So joining of polythene bag is the best example of hot tool or heated tool welding. If you are not seen, you can just go and see. Whenever you go, many times in surrounding, in day-to-day life, we are observing many of the engineering principles, but we are not looking at that as a engineering principle point of view. You are just observing it as a regular or routine process. There are many things which we are coming across, and as a engineering point of view, if your vision will be there, then you can understand the things. So hot tool welding or heated tool welding, best application is joining of polythene. Now this is not only limited to joining of polythene bags, but there are many thin plastic sheets which are joined with the help of this. So don't look at the single product or batch process. Batch process means 100 bags, 20 bags. But in industry, there is a mass process. Thousands of the plastic sheets are to be joined at a time. Or there are, in this way, just I will show you the example. So this plate I want to join with this plate. And it is having more width, more maybe 1 meter or 2 meter width. So to almost 6-7 feet width is there. And this I want to join here. How can I make it possible? So there are roller type arrangements, or there is, by putting the large 10 feet plate, it will not be economical. Then roller type arrangement is made. The rollers will roll over this superimposed or joint area or matching area, and then the roller itself is hot, upper roll hot, bottom roll hot, and then if it moves over it, you will find that this get joined, and in this way one sheet to other, one sheet to other, one sheet to other, continuously joining will be possible. So this details about hot tool welding or heated tool welding we will see in the next class. Just wait. Okay, 1 minute. So today we have started with welding process, and the classification of welding process we have studied, and out of that one process was finished, and this second process will be completed in the next class. So I repeat that many of the students have not made attempt of quiz number 1, so please complete it by today only. Next quiz will be given within next 2 days. The notes are available, you can start taking the notes. I have put it on the link. Okay, thank you, we will stop here. Thank you.